Hey Alvaro, how are you doing?
Hello, good morning. I'm doing very well, thank you.
This is my Spanish accent right now, right?
It is absolutely perfect.
I see.
I really appreciate it.
Hey, perfect. So the last time we talked about Postgres and a little bit Ongres, your company, and we unveiled that you only founded three companies. I assumed more
Right,
than this, but three companies is okay, but not like almost serial. How to call it? Serial entrepreneur, right? So this is
right,
yeah.
right.
And what's what interests me, you are a Postgres committer, right?
I'm not exactly committer because I mean, to the core Postgres project,
Mm-hmm.
that's Postgres built in C. I'm not that much of a C programmer. I can do some C code. Actually, some people
Mm-hmm.
from the Postgres community one day told me that I code C like if it were Java.
Mm-hmm. Very good.
I don't know if that makes some sense or not. But I actually have committed code to the Postgres project directly. I developed the Scrum authentication library for the JDBC driver for Postgres. So I guess that counts.
Okay. No, because what I was curious is your company is around Postgres,
Mhm.
and the and you are open source guys, so you're contributing stuff back,
Yeah.
and the question is, how to find out what is missing and how you contributed it back. You know what I mean? So
Yeah.
if you yeah, this is what interests me. So JDBC driver even more interesting because I'm a Java developer and I used JDBC driver from Postgres all the time actually. So what is the authentication library you did? So what you contributed exactly to the JDBC driver?
Okay. So that means that you're most likely using my code every day. Um,
No,
hope it
thank you.
works.
Yeah.
No, so well, first of all, let me say that I'm very very pleased to be back here. I really really appreciate you having the opportunity to talking with you again. It's honoring for me. Um, and yes, also wanted to mention that I consider myself a serial entrepreneur. I just prefix it by 0.x serial entrepreneur since I haven't done any exit yet. Not that I plan
Ah,
either. Being a bootstrap company, I don't plan for that. So anyway, I'm quite happy with the status, but I mock myself saying that it's a 0.x serial entrepreneur. Anyway, back to the topic you asked. Yes, so there was, Postgres. Let's talk a little bit about Postgres authentication, right? So when you connect, Postgres has a custom protocol, custom TCP-based protocol, which you use to connect to from any client to the server, right? Um, and this custom protocol has authentication mechanisms, like anything in the world, right? And it supports multiple authentication mechanisms. It's quite flexible from this perspective. Most of the time, or most of the most used authentication mechanisms are password challenge type of mechanisms. In the past, there was some like even supports like very old, obviously deprecated. Nobody should use methods like sending the password in plain text over the TCP channel, which should not work. So most people settled on what's called MD5 mechanism, which is uses MD5 hashing algorithm to hash the password and not sending the password in plain text. So the server kept a copy of the password hash by MD5, and then it validates that whatever you send hash also matches the hash in the Postgres server. Pretty simple, pretty straightforward. Now it has several problems. Obviously, one of them is that MD5 it's already kind of a broken or easy to break hashing algorithms as of today, but it also didn't exhibit all the properties like it is also possible to brute force via using rainbow tables hashing algorithms, right? This is also well known in the security industry. So even if you change the algorithm, you will never get to a really proper secure identification algorithm in this case by just sending a hashed version of your password. It needs to be somehow salted. That is part of it. And the other thing is that it also doesn't allow to understand from a client's perspective if you're talking to the right server. So, Postgres also supports SSL and SSL certificates in all possible ways, like without validating certificates also with client certificates. But this is kind of a session level. What we're talking here is about user authentication. So on top of this or without this, that depends on your configuration, you may want to have a user authentication mechanism. But from a user perspective, again, if there's no use of SSL or SSL certificates, or you're trusting blindly the server certificate, you may also not know which server you're talking to. So at some point, there was an authentication mechanism, general framework for authentication mechanism called Scrum. It's an RFC, so it's a standard in the internet. And it's a much more modern authentication mechanism, which exhibits very good properties. It does multiple rounds of hashing with also well-known algorithms, which are called BPFKV2, or I may have swapped some letters around. It's been quite a long time and they're complicated.
It's like a key derivative function or something like this, right?
Yeah. Exactly. You're absolutely correct. So Scrum, again, first of all, is a kind of a framework, so it supports different variations, models, or different schemes, but based on basic principles. Key derivation, thank you for pointing that, and also the fact that the key derivation happens also based on challenges sent by the server, verified by the client. So basically, client verifies server, server verifies client, and then all the magic happens with key derivation. So you never send anything that is static. It varies over time, and both ends of the spectrum can authenticate each other. Mm-hmm. It also supports something very interesting, which is called channel binding, which is introducing in the mix data that is extracted from SSL channel, if there is such an SSL channel. So you can get an identifier from the SSL channel and introduce it into the mix, so that there's kind of two levels at which this validation is performed. Long story short, it was highly desired to support Scrum as a replacement for MD5. And on version 10, if I'm not mistaken, Postgres added support for Scrum authentication on the backend, like on the database server. So now clients had to develop this. C-based clients, they use a shared library produced by Postgres project itself called libpq, and therefore it was implemented libpq, and it was supported. And then it was needed to do in the drivers. So I took on this challenge and wrote a Scrum library in Java, generic, not fitted to Postgres in particular, just a Scrum library. Funnily, Scrum also uses or reference some other RFCs. One of them is called string prep, which is used for preparing a string, which the main purpose, in case audience is interested, is basically some strings may look the same for humans, they're not for computers. I'm talking about weird UTF-8 accentures, ligatures, and whatnot, right? And to prevent problems from users being really confused, string preparation allows to say, an A with an accent and an A with a slightly longer accent are the same, or not. You can choose.
So you normalize the emojis, basically, right?
Basically, it's normalizing strings, yes. Again, very well put, yes. And emojis may mean whatever. Yeah. And so it's also a framework which defines like a set of rules. And then you can say, I want to apply rules A1, A7, B2, and B7. And that's my string prep decision, right? So Scrum relies on string preparation, also for comparison of strings. And what I did is basically write a library in Java. It's simple. The code is not very long. One for supporting Scrum directly, and one for string preparation. And Scrum library depends on string preparation. And then I submitted a pull request to the Java project, did a little bit of glue code, and implemented Scrum on the Postgres JDBC driver by importing these two libraries. Fun facts, I don't know if they are fun, but at least curious facts. These two libraries were the first time that the JDBC drivers accepted a third-party dependency. Up till then, and I believe that's still true as of today, I'm not a maintainer of the JDBC driver. One of my colleagues is. I'm not directly, but I contributed this code anyway.
Colleagues from your company?
Yeah, actually, yes, from
cool.
my company, from Postgres, Jorge. He's one of the JDBC driver maintainers. And that was, by the way, he was not by the time I submitted this code, so it's not that he helped me in any way. Anyway, I believe these two projects, these two libraries are the only external dependencies to the driver. Everything else was by philosophy just built in. There was no third-party dependencies in the project. Second thing is that...
But one question, but the JDBC driver still ships as a single jar. So they unbundle your library and package everything together, right?
They're shadowed, yes, into the jar, yes.
And are the libraries available from somewhere direct?
Yeah, they're on GitHub.
Where?
I think it's github.com/ongress/scrum.
Okay.
For better links to string prep.
I
Actually,
have
a lot
one
of projects have taken over this library. There's a lot of derived drivers from the Postgres JDBC driver. It's a driver that has been forked multiple times because there's many databases that derive from Postgres. So there's many Postgres forks. Therefore, when forks do change to the protocol, they need to change the drivers, and then they fork the JDBC driver, and therefore they're also users of the Scrum library. So actually it has a lot of projects that are using it directly or indirectly.
Are this project also contributing back?
I definitely consider that, yes.
Because this is why I'm asking is because if they don't do this is the beginning of the end because they created their own fork and get
forks. No, to be honest, not too much.
Oh, really?
Yeah.
But this is strange because if I'm an enterprise project and someone considers to fork something, I always say we have to contribute back. Otherwise, we get two forks and in one point of time, we are two separate projects. So it's really harder and harder to maintain. So I think the only way to have a maintainable software is to contribute back and use our own features, in the next release.
I absolutely agree with you, but this isn't what has happened much in the Postgres world. And this I can bring up a story about this. It's a really interesting case with a lot of twists.
Before you tell the story, I have one question because what interests me was your Scrum implementation. Have you used Bouncy Castle or something for that?
That was exactly the second topic I wanted to bring about this. So yeah, I'll keep the story for later.
Because it's okay. Then I will tell you something. I had to do some encryption as well. And I use first Bouncy Castle, but Bouncy Castle has also some security risks. So if you don't keep it up, they have a security flaws. And I took a look at Java 21 or 17 back then, and it turned out everything is supported by Java. It's a little bit harder. It's not as convenient. So I built actually everything, and it sounds very similar to your protocol. It was the push notification protocol. And I implemented, there's also no PK, the derivation function, whatever, and I implemented everything with stock Java. Yeah. And it was, sometimes it was harder because a little bit math, but it was not bad, but I could completely remove Bouncy Castle. So this is what I wanted to ask you about that, because I just have now Java 21 and nothing, which is actually pretty cool.
Remember from the last episode that we said there's a lot of parallels in our life. Well, we've got another one here. So you'll see. Here's what happened. At the time I started writing this library, it was a time where the Java driver had only versions for Java 6 and Java 7. It was that age, right? There was Java 8, but it was not used. And the rule number one when you write crypto, unless you're a crypto specialist, which I'm not, I know some stuff, but I'm definitely not a specialist, is you don't write your own crypto. Like, no way, right? So use someone who has done it. I looked at Bouncy Castle, but Bouncy Castle I discussed with the JDBC maintainership team when I started doing this, and they saw it like, this is a big thing. This is a big dependency. They didn't like dependencies at the time. So selling the idea of Scrum as an independent project because it could be reused by all the Java projects was acceptable. Bouncy Castle essentially wasn't. And I said, okay, then there's only one way out. If you want me to write, because it was kind of, I suggested to do this, but also there was kind of some help wanted from the JDBC maintainership. I jumped in, blah, 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 volunteered for doing this because I wanted to contribute back to the Postgres community in a direct manner, also contribute in indirect manner many times. But anyway, so I said, okay, my only condition is if you don't want Bouncy Castle, I'm not going to write encryption by myself. The only option is to use Java 8 because guess what? Java 8 already includes all the crypto that we need. Yes, I needed to write some code on top of it to call it, to prepare it, to do the iterations. Yes, but that I don't consider the crypto stuff. And that was the only condition. So it's actually been there at least what I needed for this project was already built into Java 8. So the code was much simpler, but it's especially crypto bugs free. At least at the same level as what is implemented in the JVM, right? Java 8. So I forced the Java driver to switch forcibly to Java 8, and they had to stop supporting Java 6 and Java 7, and they did so. So it was a trade-off, I think a reasonable one. Anyway, Java 8 was a huge shift from Java 6 and Java 7, so pushing people to use Java 8 was probably not a bad thing. Fun story on top of this story is that a couple of years later, we got a request from a customer. Actually, it was another Postgres company who partnered with us because they had a customer that needed yes or yes to run on Java 7. And they wanted a backport, but they also needed Scrum. So they wanted a backport of a Scrum library on Java 7. So for this one, we created a fork of the driver that used Bouncy Castle.
And you mean Ongress?
Ongress, yes.
This
was a paid job.
Yeah, this is good, because now we have an example what you actually can do, right? So if there is such a thing, there is where Ongress kicks in. You can fork whatever is to fork and help your clients. Okay, exactly.
Yeah.
That's interesting. So really a parallel universe, and I'm also not. It's a who is encryption expert. I think to call yourself an encryption expert is if you work all the time with security, right? Because it changes too fast. There's no other way. So then you are only an encryption expert. But what I did is I found in RFCs and old tests. So if I run the tests, then it will not Java RFCs and the internet RFCs about the encryption. And say, okay, if it runs, then runs, and it runs. So I just converted the RFCs to JUnit tests, and everything was successful. So okay, then it has to work, right? Okay.
Yeah. Actually, I wanted to do something similar for the string preparation RFC. There's a lot of tables, like codes to translations. And to be honest, I didn't do that, but I started some basic code where I wanted to actually write. It was not tests, but it was kind of a pre-generation step, so code generation technically, by fetching the RFC, parsing the RFC, and extracting all these constants and these codes and created enums with that automatically. I didn't end up doing that, but it was a huge temptation. I wanted to do that. It's
so what I actually did in a project, this was also a funny project for healthcare, finance, there were spreadsheets with data, and we had to implement the calculations, and we were not sure whether our code is worked correctly. And I had to work with non-Java programmers. So they understood Java, but for instance, interfaces were already hard, or inheritance was already hard. So I could write simple Java code with static method, but nothing else. And what we did is, this would actually work for you as well, JUnit tests, which were parameterized, and we parsed Excel and parameterized the unit tests. And now it comes. The result was written to another Excel sheet. And we had cells. Red was error, yellow exception, and green was okay. And the cool story is we only had to modify, the code until everything was green, and they were highly productive without me, because it was the Java looked like C,
Right.
Or, and you could also do this. You don't have to generate enums. You could provide, I think it's called not data source. There is a CVS source or whatever for unit tests, which parses your tables and feeds the tests, and you get the parameters directly from table, not from enums.
Right. Yeah. No, absolutely. Any approach like this could have worked, of course.
Yeah.
In this case, it was literally part of the code, because it was tables that you need to use for conversions of codes, right? So it was code.
But it's a hard stuff you did, actually. It is incredible. Scrum, I think, it is. What do you explain is actually not an easy project.
It was not that hard, I would say, but things that I hadn't had to implement my own crypto. that was the main key. I mean, the source code is there. It's not very big. It's a few thousand lines of code.
Yes, still, but you have to think. There are small things, and crypto. If you do something wrong, I remember. I spent the entire night using the wrong base64 encoding. This is what I remember years ago. Because they are URL encoding and whatever, and I don't know, I was not cautious, and I used the wrong one, and nothing worked, because you get no feedback if something doesn't work. So,
yeah. No, and then I had to glue it into the Java driver, because I also write the glue code to import this library. And the JDBC driver from Postgres is not an easy one. It has, it's modern code today, but has still a lot of legacy code. For instance, when it started, JDBC was JDBC v2. which I don't know if anyone even remembers or know how it is or what it is, right?
Mm-hmm.
And so it has, and current JDBC 4 version is implemented as an interface, or I mean, there's a lot of interfaces and abstract classes on top of JDBC 3, which is on top of JDBC 2, like whatnot, right? So there's kind of a lot of legacy that is not easy to remove. It's not also harmful, but you need to navigate all this to understand how the code works.
Mm-hmm.
But yeah, that was one of them. That was one of them.
On that note, what I had to do in a bank project, it was Oracle project. So if you have application server, you use username and password as a resource user.
Mm-hmm.
But what they needed for audits is if they wanted to see in the database the actual user, not the resource user.
Mm-hmm.
And there was a proprietary extension from Oracle. So we had to cast the JDBC connection to Oracle connection, and then I can switch the user for a brief moment. Or I don't know whether switch, I can attach the metadata of the user. So we saw in the logs of the database, the user did actually that. Is it possible with Postgres? You know it out of the cuff, whether there is such a functionality that you can tell the current connection, I'm actually the user, and you will see in the database somewhere, this is the user Duke.
Yeah, there's two ways of doing this. Totally different ways, right?
Yeah.
With different advantages and disadvantages. One is that there is a parameter called application_name.
Mm-hmm.
And it's a free string that you can just set to anything that you want at any time, and it will get logged. If the server is configured for logging this property, it will just get logged. So you can pass anything there. Super easy. Yeah. And you can set this as a parameter in the URL connection string if you want to, and you'll set your application name to whatever. I mean, normally it's used to set the application name, like your own application, and all users will have the same application name, but you can do whatever you want.
But you can do it dynamically per connection? Or
yes.
So if you have already the connection, because the connection is pulled, right? So if I have the connection instance, can I switch, still edit? You know what I mean?
I mean, if you have a pool, that is going to be on the pool side. So if the pool already, if
that's the problem.
Reusing a connection, it will get reused. Unless once you still have the connection, you can do a set and change the parameter dynamically. And then, this is what we did.
This is what we did. Okay, cool.
Yeah. So that's one option. The other one, which is more specifically to users, is that Postgres has a quite advanced user system or role-based system. And it basically supports roles that is kind of an abstract thing. Let's say it's a parent for both users and groups. And then you can create a user, and you can assign permissions to the user, groups to the user, roles to the user, and whatnot. And then there is a mechanism which is called set role. And you can set, it's kind of a pseudo, right? So it's like, except it doesn't need to be root. So you can set role, and then you're changing to another user if you're permitted to do so. So you can connect, the connection can be one user, and then you can set role and become another user if you're allowed to. If this is a hierarchy that you're allowed to do that. In this case, you can change the user effectively of the connection.
No one asked me about that right now, but back then lots of companies wanted to have it. So in different levels, we always did it. And sometimes we even had to hack the connection pool and sometimes the driver. Okay. So, but I interrupted you multiple times. You wanted to tell me a story, an interesting story. And yeah.
Okay. So here's the story about a fork, a Postgres fork, and then I can also tell you about other ways I believe have contributed to the Postgres community through my companies. The story is an example of a fork, as a Postgres fork that didn't turn out to be very contributive back to the original project, and even though at some point it was tried. Anyway, so here's the story. It's called Greenplum. And Greenplum was originally a fork of Postgres. Postgres is liberal licensed, right? It's run distributed under the Postgres license, which is a slightly derivative of the BSD license. So a liberal license from that perspective, right? You can do anything you want with the software pretty much, while you keep the license notice. So Postgres has a lot of forks, proprietary and non-proprietary. I'm more of a person who likes copyleft licenses. So if there are forks, they keep the same rights of the original project. So technically, you can contribute from those projects directly to the original project. So I believe they're more community focused in this regards, but that's a different discussion. Anyway, so Greenplum. Greenplum was a fork of Postgres a long time ago that wanted to add more data warehousing capabilities and distributed capabilities to the database. And it's a great database, and they have achieved a lot of improvements for Postgres. And it's a data warehouse based on the Postgres core. Now, it was initially a proprietary fork. And then at some point, many years later, it became open source, still as a fork, right? Because it was quite different code base. But it was stuck on a very old version of Postgres. So they hired a lot of people from the Postgres community, for Postgres main developers, to help them regain parity with Postgres itself, right? So porting back from Postgres to Greenplum. Actually, I did participate in that project. I backported the original JSON data type implementation of Postgres to Greenplum.
In C.
So in C, yes, in C.
Yeah, you told me you never contributed anything because this is a C, but this was a kind of.
It was, yeah. It was to Greenplum, not to Postgres, but
Yeah.
I guess
But yeah,
could go possibly.
Yeah.
I mean, it was basically, it was not programming. It didn't write the code. It just ported the code.
Mm-hmm.
So Greenplum was on 9.4 and Postgres was already in version 12 or 13, whatever. And I took old code from Postgres 9.2, which was the original JSON data type implementation, ported it to Greenplum. And a lot of engineers were porting Greenplum. They reached parity with 9.2, then 9.3, then 9.4, then 10, then probably 11, I don't know. And the goal was to reach parity with Postgres and then try to start merging code bases so that at some point, Greenplum could become an extension to Postgres rather than a fork. There's other projects which actually achieve this. For example, Citus Data, which is a distributed scheduler and sharding solution for Postgres, essentially. It started as a fork. As of today, it was retrofitted as an extension, and now it's just an extension to Postgres, which is obviously much more convenient because you just need to install the extension. You don't need a separate system. So Greenplum tried to do this, didn't achieve this. It's too much different probably at the time. So the decision to become open source was probably fueled by the idea of catching up and what you said. Let's merge into because maintaining a fork has become very expensive.
Yeah, I would say impossible, right? Because database for me is almost operating system. So you I mean you will have to have enough developers to understand, the at least for your platform, all the optimizations. What I would say, this is not the core business. I mean, to justify this from business perspective is crazy.
Yeah, absolutely. But they tried hard. They did a huge effort. They did a great job, and they converged a lot. But it was still not enough. Then Pivotal, Greenplum has been owned by companies that have been changing hands a lot of times. It was originally developed by Pivotal, I don't know if someone else before, which was acquired by EMC, then Dell, then VMware, then Broadcom, and I missed some pieces on the way. And so today is Broadcom, and Broadcom just pulled the plug silently one day and became proprietary again and vanished.
Yeah, but proprietary again means that this is the end, I would say, right?
Because unless you pay for it, it's the end. Yeah, it's no longer open source. There's now a fork out of the last version that was public. Now it's called Cloudberry, and some other people are developing it. But yeah, Greenplum itself has vanished.
By the way, Pivotal, EMC, I don't know EMC, but Pivotal, Broadcom, and another VMware, I think was the same company, bought over and over again. So now
that's the thing. But it was first owned. So Greenplum, I think it started like a separate company. Then it was bought by Pivotal. Then Pivotal was bought by EMC. Then it was repurposed to be part of Dell, and then they came back to VMware. I don't know.
But is it something like Redshift data warehouse, or
it's very similar to Redshift conceptually. Redshift is also a fork of Postgres. It was called Paraxel at the time, if I'm not mistaken. It was acquired by Amazon and then became Redshift. But it's also a fork, very distant fork of Postgres, distributed architecture with a distributed scheduler, sharding solution, very similar conceptually, different implementations.
Okay, interesting. So, and why they couldn't merge? Was it that hard, really? So, it was
very hard. It was very. First of all, Greenplum, Redshift, they serve the same role. They're kind of more of a data warehousing. They're totally different. They support columnar storage. So that's the first thing. A data warehousing.
There was a very deep
columnar
changes.
Versus row storage. You need to support both. There's also distributed, like you shard out to multiple servers, and there's coordinators that route the queries, and that doesn't exist in Postgres. Right? There's a lot of changes required to support that. I know more about Greenplum than Redshift from an internals perspective, obviously, and Greenplum is quite complex in terms of network. For example, it opens like more than a dozen ports and has a lot of internal communication between the nodes, different protocols to support that. None of this exists in Postgres, and it all requires core changes to core Postgres that they're not in core Postgres. So merging that is not easy.
Mm-hmm. And how is the Postgres community thinking about such forks? I mean, they really appreciate it, they don't care, or they say, okay, they should contribute back. Is there any feeling? Because it's interesting. If you work on something, the entire time, you're completely liberal, and you get cloned, and there is nothing comes back. So, I mean, there should be a reaction, right? So, okay, I don't care. Is this good because you would like to spread, the Postgres goodness around the world, or what's? I mean, there's always some ideas behind, right?
I would say it's kind of a bag of mixed feelings. I'm not any representative of or speaker for the Postgres community other than myself, but my perception is that some people don't care, but literally. Some people fight against this and say that they must contribute and shame companies publicly for not contributing, which I also don't think is the right thing to do. And I mean, even though ethically you could say that, legally licensed, you're not forced to do it. Actually, open source, the spirit of open source is you can do anything you want, including nothing, right? That's a valid option and should be respected as such. And there's people who believe that actually contribute, even forking Postgres can also contribute to growing Postgres in general, like the Postgres awareness. Right? I have a tweet somewhere. There's one thing I do more or less, not very periodically, but from time to time, I gather the statistics from a website, well-known website called DB Engines, which has a ranking of databases ranked by popularity. The algorithm they use for ranking databases is not very well known, like Google, like they don't publish it, but is what most people trust as a good proxy for the real popularity of databases. And they publish a graph always in logarithmic axis. I always normalize to linear axis because when you're looking at just the top 5, otherwise you don't see the difference as well. They do logarithmic because they have more than 100 databases and their popularity varies in orders of magnitude. But for the top 5, you don't need that. So normalize to linear indexes. And when you do that, you see more acute differences. And there is a very interesting tweet that I made some months ago where I showed like a huge spike in popularity in Postgres. It was kind of a step curve, right? Like it's growing and then a huge spike and then keeps growing. And that point of time where that popularity of Postgres increased so much, do you have any idea what it could be the time around?
I would say when Neon and all the other happened, but no.
It's a good guess, but it was even much earlier.
Okay.
So it's basically the month after, but literally the month after
Oracle
RDS Postgres was announced.
Oh, cool.
So I see sometimes.
My second guess would be, as Sun bought MySQL and Oracle took over, because then everyone moved from MySQL to Postgres. Maybe this would.
I guess that was the case, but the data is only the acquisition predates the data that is available. Okay. I'm sure that was absolutely the case. But this is quite interesting. So sometimes people say, like, Amazon is not contributing to Postgres. By the way, now Amazon is contributing a lot to Postgres. But by then, like years ago, some people were saying Amazon is not contributing to Postgres. And I showed this graph as like, well, indirectly maybe, but I'm pretty positive that AWS hugely contributed to the popularity of Postgres, which is good for everybody in Postgres.
But I had some... I forgot the projects, and I think the AWS contributes a lot to open source projects.
Yeah,
for various, but they do it really. How to call it? They try to be the perfect citizen. So I had a chat with someone, and they say, okay, they spend a lot of thought to know how to do it right. So this is not like just commit code, but if they do, they try to do it correctly, which really surprised me. So I thought more, like we throw the code back and we don't care. This was the opposite was actually true. They spend a lot of time to thinking, and they contributed. I forgot the project. It was not Postgres. It was
Fish, maybe.
Babelfish, maybe Babelfish is what you can run.
Firecracker, Bottle Rocket.
Yeah, Bottle Rocket. It was it was an Amazon project, and they used that for their own data store. And this was not Iceberg, but similar. Not Iceberg. It wasn't Iceberg, but it was similar.
Well, I can tell you an example I know from the first hand, which is Bubblefish. So Bubblefish is a Postgres derivative that adds SQL Server compatibility. So it speaks the SQL Server TDS protocol, it speaks the SQL Server dialect, and even supports stored procedures in the T-SQL language, right? So it's a drop-in replacement for SQL Server. And this project was developed by Amazon, was published as open source. And actually, Amazon hired Ongres, my company, to help them engage with the Postgres community and to prepare the documentation and the code and the committers, the contribution guide, and the website. We really helped. They were very, very interested in making this project a first-class citizen within the open source world.
I didn't
so
know that.
It's
cool.
exactly what you're saying. I've seen it because we've been even contracted to help them do this because they had this vision. They said, no, we're just not going to dump the code there. And no, we're just going to put the code there. We're going to engage with the community. We're going to explain what we're doing. We're going to document it. We're going to explain people how we can contribute and all that. So they did, and we helped them do such an effort to do that and to really, really contribute in a very high quality way, I would say.
I remember. You know what it was? It was a Lucene related project. Something with Lucene. I didn't thought that the AWS, will contribute back, and they spent a lot of time and they found some performance or whatever, and they contributed back to Lucene or Lucene's similar project. I'm not sure whether it was Lucene. Maybe it was
OpenSearch.
But OpenSearch is their own project. This would be a no-brainer. But
it's probably because OpenSearch uses Lucene. I guess that kind.
This is around Lucene. Okay. So another question, because we talked already about JDBC. So you're using obviously Postgres JDBC, I guess, somewhere, right? So are you configuring anything for performance or whatever reasons, or you just go, with the conventions?
No, Postgres is an example of a database. So there's two things. One is JDBC configuration or tuning and Postgres tuning, right?
JDBC.
So from Postgres perspective, I'll be briefly about it. Postgres has around 300 connection parameters. And the configuration, the default configuration for Postgres, I always say is equivalent to running Postgres. It's tuned for a Raspberry Pi 2, something like that, right? So if the question is, should you tune Postgres? Absolute must. It's like running a Ferrari and not being able to go past the second gear. You're underutilizing it by all means. So tune Postgres. We actually at Ongres, we built a free service called Postgres. The main Postgres configuration file is postgresql.conf. So there's a URL, which is postgresql co.nf. So just shift the dot 2 positions to the right. And that is a website which will help people configure Postgres. It's a free service, nothing attached. It's just a contribution to the community. And there is help with all the parameters there available, translated to 6 languages. And it's just a way to get help about tuning Postgres. So that's one thing. The other thing is
this is now Postgres tuning, right?
It's Postgres tuning.
Okay.
Yes.
Backend. Okay.
So about JDBC. JDBC itself does not require a lot of tuning the parameters. What is really, really important is to use a connection pool, and B, to size appropriately the connection pool. That is absolutely critical, on the other hand. There are certain parameters you can pass to the connection string. If you're dealing with SSL certificates, you may want to use some parameters. If you want to force some configuration, for example, I want to force that I need to validate the server certificate. This is a parameter that you're passing through the JDBC URL, and then you must use it if you want to enforce those kind of things. Otherwise, Postgres is quite lenient and will connect, as long as it can connect. So these kind of things, if you need them, you need to force through the parameters. But other than that, username, password, credentials in general, that's pretty much application name. Some people use it to set it. We discussed before, right? Those are the kind of things that you typically tune. But what is critically important is the connection pooling. So Postgres has this model where for every connection, it starts a backend, and the backend is backed by a OS process. And this process has some caches, and essentially this means that creating a process is not cheap.
How slow is it?
It takes milliseconds, but it creates memory pressure. a backend could use approximately almost empty up to 8-9 megabytes of RAM. Which doesn't sound like a lot, obviously, but if you start creating thousands of connections, it really adds up. Right?
Yeah, this is why I'm asking you. You may already know why. RDS and Lambda, right? Which purpose? Yeah, whether we need RDS proxy or not, really, because for a smaller project, it's good enough. But if we have lots of connections, then it changes, right?
Yeah. So in general, yes, I strongly advise to run a connection pooler, whatever it is, at whatever layer it operates with Postgres. Because most people assume, especially, maybe Lambda is like a different case, but not too much anyway. But the typical use case for an e-commerce or a web application where you have thousands of potentially users and then a database behind is that most people assume a one-to-one mapping between, a user request and a database connection. And that, Postgres can handle that, but the performance is going to be really poor. Postgres is this database that you can throw
What do
anything.
you mean by really poor? Because in my project, so I get hired task forces when sometimes Postgres is too slow, but usually it's never Postgres. Is something wrong with JPA transactions or locking or whatever. But really slow means in my world, I don't know, the user is waiting 5 seconds until something happens. And in your world, too slow is what, 10 milliseconds? Or what is slow?
I'm a data person. I always like to quantify things, and I just said an unquantified statement. So let me quantify it. I have a presentation that is on my speaker deck on my personal page, also called Postgres Configuration for Humans.
What is your personal page website?
It's aht.es, Alpha Hotel Tango Echo Sierra.
Okay,
easy. So there I just have a copy of all my presentations and slides and videos. There's close to 150 as of today now. So there's plenty of material. Java, Postgres, Cloud, the most represented ones. So I have a presentation called Postgres Configuration for Humans. It's already several years old, but it's the one that has been downloaded and visited the most by a far margin, like orders of magnitude. And it's just about tuning Postgres. And there I have a slide talking about this problem of connection pooling, right? And this slide shows a benchmark on a tiny machine. I think it's like a 1 or 2 core, 1 gigabyte of RAM machine, right? Where I'm running a test, a benchmark, right?
And 500 euros in the cloud for Postgres. This is per month.
By the way, we did some project where we did some benchmark, and we spent close to 50K on Amazon for that benchmark. That was not planned, to be honest. That's another story. Anyway, so what I do with this benchmark is increase over time the number of connections. So I did the test with 10 connections, 50 connections, 100 connections, 500 connections, 1,000 connections, whatever. And graph first of all the transactions per second. And you look at the number of transactions per second is 500, whatever, 5,000. I don't remember the number, right? And it's almost constant. Actually, it grows slightly as the number of connections grows. So you say, wow, Postgres works very well. I can throw 500 connections to a 2-core server with 1 gig of RAM and delivers and actually increases performance slightly. But then on the next slide, I add the latency on top of the same graph. And you see that with 10 connections, the latency is below a millisecond. And with 500 connections, now the latency is over a second.
Okay.
Right? So that's what I mean performs poorly. Like performance degrades, the latency, the transaction. If you look at TPS, transactions per second, you're going to believe everything is okay. But if you look at the latency, and definitely high P percentiles, the latency spikes very fast as you overwhelm the server. So typically, my rule for configuring the maximum number of connections that a Postgres database should accept, it's something in the ballpark of a small formula, like a linear formula on the number of processors that you have. Let's say, to simplify things, 5 times the number of processors cores. So if you have 2 cores, you shouldn't be having more than 10 connections, because each connection is going to create a process. And unless that process is doing I/O, which is that's why we use more than 1x, if it's doing I/O, obviously it's suspended. But if it's doing queries, and the data is in memory already because your data set is small, for example, then you're just using CPU. And if you're having 2 cores, you cannot use serve more than 2 queries at a time. The OS can, because it will do time share, but you are starting degrading performance. And once you reach a saturation point, it degrades exponentially. So you can
And
tolerate a high number of concurrent connections, but the performance, the latency will not be very good. Could be
and
very
you
bad.
reopen the connections in your test, or you pull the connections?
No, so if you set up a connection pooler, then you're opening a connection, and then you can share the connections. You save the startup cost of those connections, which if you're using SSL could also be not expensive and not cheap at all. But then
How slow is it? This reestablishing the connection without pull.
I mean,
Is it somehow proportional for the number of connections? Because in your
no.
test, what I understood is you pre-pull the connections, right? So you have okay.
Yeah, connections already established. Yes, with the latency of establishing a connection in Postgres, if you're using SSL, it's the cost of paying around a little bit less than a dozen network round trips. So it depends also where is your database, where is your client. We're talking milliseconds anyway, right? Unless you're doing cross continents, but there's quite a few round trips in total, like around a dozen. Yeah. Network round trips.
Why I'm asking such strange questions? Because most of my projects, so I do a live stream once a month, and even the last one, I got the question, why I'm not talking too much about JPA, which is JDBC related in the cloud, and the problem I have. So most of my projects were Java EE, Glassfish. We had the discussion already, Whitefly, and so forth. And in the cloud, I always use Quarkus so far, and this is the old code basically. And it runs like a lambda lith. I like actually the term. So the lambda lith is a huge Java application, which is actually fast. But if you will attempt to call Postgres in the cloud, then you do nothing. So first thing is you have to tell developers, hey, look, we don't need the connection pool anymore because we are alone. Lambda is like one process. There is no threads, and if they open 5 connections per lambda, then it is killed immediately. But let's say then you have to reopen basically one connection over and over again. So if we get 10 parallel connections with lambda, it means for every call for cold start, it will completely reopen a new connection to Postgres and then close it. So this is my situation. And if the lambda remains warm, then the connection is up. But otherwise, it gets shut down and reestablished. And it works well for enterprise projects because this is usually there is no traffic, right? But if you hit some traffic, I think the RDS proxy, which is like connection multiplexer, has to be used, but it adds additional complexity, and this is why I basically my project I'm using S3 or DynamoDB so far because it is HTTP. But this was the question I asked you why it works, how it works, right?
You pretty much laid it out. Like if you need to reestablish a connection, that is going to take time because of these round trips, because of you're using encryption and all that, and it just takes time. The protocol is a bit chatty in terms of round trips. It's not designed for this. So the only solution, the only good solution for this is to have a connection pooler that has already the connections established, and you save that cost. So the cost in terms of computing resources and latency, you're going to pay the bill for that, right?
But the misunderstanding is that the connection pool cannot be inside the lambda; it has to be outside, and the only way to do this is with RDS proxy. So now. Dynamic question right now, RDS proxy. Do you have something like an RDS proxy offered by a company?
There is within the Postgres ecosystem connection poolers. RDS proxy is just a connection pooler, right? Maybe a bit glorified with some more integration with Amazon, but still a connection pooling. In the Postgres world, there is multiple connection poolers. So one of the things about the Postgres ecosystem is that there's many options, which is both good and bad.
Which one? If we would create our own cloud, let's say we have Lambda-like stuff, and we have a small machine, and we would like to install our own connection pooler from Postgres. So, which one would you suggest?
The one that we use in Postgres, for example. So right now, if you create a cluster with Postgres, it will come with a connection pooler by default. You can disable it, but by default, it's going to install one. That's how strong our philosophy is about using connection.
Why you need a connection pooler in Postgres?
Because there's a Postgres behind, and again, because most people. So here's the usual path, right? This is what typically happens with Postgres. Someone set up Postgres for a web page, right? And then by default, then the maximum number of connections in Postgres is 100. Let's say most people don't tune this ever. Don't tune Postgres. They just throw it and start working. Suddenly the web application starts failing. Oh, there's errors from the driver. It says connection rejected, maximum number of connections reached. So what someone does, goes and raises max parameter. Google something, raises the max parameters and put it to 200. Then sometime later, the same problem happens. Then they raise to 500. Then the same problem happens. They raise it to 1,000. Then they say, okay, you know what? Let's put 10,000 and we'll never have this problem again. And then put it to 10,000. A few months later, when the application usage grows, they start saying that the database is very slow and that the queries are taking a long time to respond. And it's, what is happening is exactly what I explained to you before about this benchmark, right? Because now they're opening 10,000 processes in the operating system, and they're all using 10 megabytes of RAM at the least per process. They're just having 10 gigabytes of memory just on these caches on the processes. And there's a lot of time sharing, and the OS takes the time also to schedule every process, blah, blah, blah. So the solution is to have a connection pooler. If you have a connection pooler, then the connection pooler can have thousands of connections incoming, no problem, and then a much smaller number outgoing.
Yeah.
And then the connection poolers you can configure in two modes. A mode which is called session mode, where there is a one-to-one mapping between incoming and outgoing connection, and a multiplexer mode, which is called transaction mode, where within a single connection, they can throw transactions belonging to different incoming connections. So this is a pooler who multiplexes this over time over the shared channel. They have the advantages and disadvantages, but mostly these are the two modes. Once you have as a connection pooler, then you have a sane way of keeping Postgres in an optimal regime with a much lower number of connections while queuing, from the application, the high number that you need. So there's multiple connection poolers. They all support these capabilities. The most used one, which is not necessarily the best one, but it's the most trusted and reputable one, is called PG Bouncer. So
PG Bouncer, this is what you're using in Postgres?
Yes.
Okay. But what you said, it pre-assumes that your clients or your web applications are not pulling the connections by themselves, right?
Not necessarily. Actually, I like multiple levels of pooling. There's, other than a slight trait of latency, most of the time that is not a bad idea. Because, so let's say so the question is, where do I put the connection pooler? In the application, in front of the database, or both? If I put it in front of the database, that is normally a good thing to do. That's what we do in Postgres. We actually co-locate it with Postgres itself, because then you have full control, right? Whatever number of incoming connections, I'll just queue them, I'll just manage it, and I will keep the outgoing connections very controlled. Some people say, no, I have my connection. Typically in Java world, almost everybody uses a connection pooler in Java world because it's very easy, right? So I have it on the client. Now, the problem is when you go to a dynamic environment, let's say a cloud environment, could be Lambda, but could be also VMs, right?
Yeah.
You have auto-scaling. Yeah. And if you have auto-scaling, now the number of clients is not well known.
Yeah.
Right. So how do you dimension now your connection pool to not overwhelm Postgres? Well, unless you size your pool dynamically according to the scale of the number of servers, which no, right? Then you might be overwhelming or underwhelming Postgres. So these you can also fix by having a connection pooler just for fronting Postgres. Even though you're doing two levels of connection pooling, if you can pay that latency, the network latency adding for a connection pooler is negligible, right? So
yeah, for you makes absolute sense, because Postgres is for me like almost like a private database cloud, right? Which can be public, but you can also gain some observability because you can see what happens on the middleware layer.
Exactly.
And in my world, enterprise world, it is not that sophisticated. So what they have one Postgres, one project, and auto scaling is not used mostly. So they have there's a huge waste actually. So what I observe is what happens is I think it already happened, but it in the last years they just moved their workloads directly to cloud. They found Kubernetes and then were overwhelmed by Kubernetes complexity. So they built around something, and then they basically shipping two virtual machines with one load balancer to the cloud. And it sits idle and does nothing. So this is basically so. This is a little bit exaggerated observation.
Yeah.
And but it is going to be expensive, more and more expensive. So now it's the time, where we get new contracts, to fix the problem, because it is if you do this, it is really way more expensive than on premise.
Yeah.
Okay, that's interesting. So you already maybe we should only briefly introduce Tigris because we spend a lot of time with oh no, before we introduce Tigris, the last question, because it's Postgres related. So there is an interesting database called Disco or DSQL, right?
Yeah.
Dynamic SQL. Yeah, this is a Postgres based database which I think doesn't need pooling, right? So it is Postgres compatible, similar to DynamoDB, which is
Mm-hmm.
Postgres compatible somehow. So it's not all the features, but at least it understands SQL. And have you experience with it?
Yes. So actually, it resonates with one thing that you mentioned before. I wanted to highlight that is very important. You mentioned that there's no HTTP protocol for Postgres, and that is true. I think this is a missing feature. I mean, Postgres has its own traditional protocol, and having another protocol is a big deal because you need to change now all the drivers. Now, I've participated in conversations about this. Actually, I wrote part of a kind of a wiki page. Postgres uses wikis, very old ones, for designing a new version of the protocol. And this is not going to happen, apparently. But I have ideas about which things should be in a new protocol. One of them is that it should be HTTP based. In particular, I would say gRPC based. And it will have a lot of advantages, not only by reducing the number of chattiness and messages exchanged back and forth multiple times, especially if it would be based on top of HTTP3, which has precisely optimized this path of very, very low number of round trips. I think would be great, not only because of reducing this problem that we are discussing today, but also the latency in establishing new connections, in which case minimizes also the need for connection poolers. Actually, HTTP 2 and 3 also allow to multiplex over a single channel, so it also reduces notably this problem of connections in Postgres. There is a database which implemented experimentally exactly the same combination, HTTP 3 gRPC based new protocol for the database with excellent results. It's Vitesse. It's MySQL based sharded solution, and I think this is a one way that should be explored, and at some point should be explored. Now, why this is related to DSQL? Because DSQL also a little bit follows this pattern. You just are given a TNS name. You're still using Postgres protocol, but you just connect, run your query, and go, right? And it just works, and it doesn't require connection pooling. Well, why? So what is DSQL in reality? DSQL, it's based on Postgres. So it's compatible because it literally uses significant parts of Postgres code, in particular the query parser, and a little bit other bits and the protocol. But it has its own connection pooling inside. Why? Because of the nature of this architecture itself. So DSQL is a distributed database. Like we have also the Postgres compatible distributed databases like Jugabyte, for example, which is also open source. What it does is that when you want to scale a database, so Postgres architecture is basically single writer, multiple readers, right? You can have a primary node and replicas you can do read-only queries, primary, read and write. Postgres scales vertically very well, up to thousands of cores and like millions of transactions, a few million transactions per second you can do with Postgres. But at some point you need either more performance or less risk. I mean, if Postgres primary fails, one of the replicas can be promoted, but this takes time. There's a bit of a downtime in between, right? Some people cannot tolerate this either. Or in case of disasters, you may be down for hours, whatever, it's a disaster situation, then you're down. So to minimize risks, sometimes you want to have multiple writers, right? Yeah. So if one fails, okay, maybe some % of the users are down, but not everybody else, right? So,
but actually, I would like to have always writers everywhere where they magically sync with each other, and the follower and leader is already a shortcoming from architecture. Because the cool part would be if I have truly distributed database, which is hard to implement, but around the world, so what AWS or Google Spanner are doing because they have the hardware for it. But this would be, right, from the architecture perspective, the cool thing that we have just masters or just leaders, and there are no followers. It would be the best thing ever, I would say.
Absolutely. That is the desire that we all have, and that is actually the promise of DSQL. Now, reality is that there's no free lunch, right? Yeah. So there's always trade-offs. And so distributed databases, actually, that's the main selling point. This is what they do. and they do well.
Mhm.
Now, it comes with trade-offs. So it's all an analysis of what advantages that brings you and what trade-offs it doesn't, right? It does also
Mhm.
bring. Now, from an architectural perspective, what essentially distributed database does is internally it does sharding.
Mhm.
First of all, so it splits the database into logical subsets, and each logical subset goes to a different shard or partition, or however you want to call it. And then it typically uses a distributed consensus algorithm so that there's no this concept of a primary and replicas, but all form a quorum and make the decision. And so that's a basic principle. DSQL follows a slightly kind of an optimized, very much optimized, very smart architecture for implementing a distributed database. And it does so in a way that actually doesn't require this kind of coordination. So it's sharded. This is no question, and that's why if you look at the internals of the
Mhm.
architecture of the SQL, there is kind of connection routers or proxies or coordinators that actually receive the implementation, then they route to the proper parts of the architecture. Well, actually, the SQL is slightly different from this, but conceptually, we can map in some way. But it does a lot of very smart decisions to avoid coordination up to the last second. So
Mhm.
most distributed databases, when you start a transaction, they need to do coordination already. Then for each step of the transaction, you need coordination for them, and then you just commit. The SQL basically allows everything to run locally except commit.
Mhm.
Again, it's all about trade-offs. What are the trade? So this is much better in terms of latency. There's almost no penalty throughout the transaction except at the end, which is where the only coordination is required. Read-only transactions to happen all locally, they require zero coordination, which otherwise normally distributed databases also require coordination even for read-only transactions. The problem is that this is similar to pessimistic versus optimistic locking. What they're doing here is optimistic. They are assuming the transaction will run through without conflicts.
Mhm.
So they allow to run locally, and then at commit time, they say, hey, is there any conflict? Then if there is any conflict, you'll get a rollback. This is okay. I mean, the database handles this. But from the user perspective, what this means is that your application, if you're writing an application, you should be aware of this, because most usual approach to working with databases is pessimistic, meaning that my transactions will just go through.
Mhm.
Actually, depending on the isolation mode, some may also be rolled back by conflicts. But if you operate like on a read in a isolation mode, where there's no possibility for conflicts, then you will never have conflicts. Now you can have conflicts anywhere. And there's retry logic to be implemented into the application. And not all programmers are aware of this. So it's all about trade-offs, right? And
Yeah.
other than that, it's an amazing piece of technology.
Yeah, I
And a
was just
very
curious to know from the Postgres JDBC perspective. So it works as expected, and the latency is low because it has, as I recall, lambda-like connection pooler, right? So it just
yeah.
comes and goes. So this is a interesting serverless approach to databases, I would say.
They use Firecracker, like
Yeah,
Lambda does,
yeah.
for the VM technology that powers the query processors, which
Mhm.
are the parts that receive the. So there's a proxy first
Mhm.
that implements the Postgres protocol, does routing, sanitizing, and
Mhm.
authentication, whatnot.
Mhm.
And then it passes the connection down to a pool of hot or warm Firecracker servers that just process a query and then go to the storage to pull if they need to pull anything from storage, and that's it pretty much, right? And then
Mhm.
if they need to commit something because a read-write transaction, they go to a specific service, which I don't remember exactly the name, but it's basically a distributed log
Mhm.
that is also multi-region, and first commits locally and then looks for potential conflicts
Mhm.
before fully committing the transaction.
What reminds me, the entire mechanism is what happened multiple levels above with JPA optimistic logs. So what you had back then were Java objects, and you can work locally and attach them, detach them, and actually attach them, and then perform some changes. And at the flash time, the SQL was generated with the version IDs, and you could get the
Mm-hmm.
conflicts there. And if you didn't did the flash, just commit, then flash and commit happened, and you saw the optimistic exceptions there. And the interesting part is really similar to the SQL, because if you were in clusters, you have two copies of your entity manager cache, right? So you could have a conflicts with yourself because you are just a clustered application. So you have two instances of the cache and one database. And now with the SQL, I would have in JPA 2 caches of myself plus the caches of databases. So I could get optimistic logs on the entity manager level plus optimistic logs on the database level. So I have twice to deal it twice with the same.
Too
thing,
optimistic.
Right? Too optimistic, right? So yeah, exactly.
So there's one thing I would say here quickly that is basically that one thing I like. I'm very opinionated here, so please beg me pardon here. But I mean, and as a Java developer too, right? I love interfaces and APIs and all that. But for me, the real API to the database is SQL. When you use technologies like JPA and other mapping strategies for connecting to a database, you're getting something out of it in terms of easiness and mapping of the results and all whatnot. But you're also losing a lot of power that is not exposed via those APIs, because those APIs are generic, right? And they're kind of the least common subset of features of any database that is supported. And Postgres is actually a database extremely featureful. Has a huge amount of features and other databases do not have. And so when you're dealing with Postgres especially, but in general applies to all databases, if you're dealing with SQL, you can use all these functionalities. If you use all the technologies on top, you will not be able to use all these functionalities. What you're talking about is something that normally you can do as a SQL level with logs. So what you're saying, if I'm not mistaken, is kind of a CAS, compare and swap operation. That basically when you're going to write something, you check if the ID has not changed, and if so, you do it. And it's something with SQL you can do with a select for update, for example.
This happens automatically. So if you do the JPA, you have an entity class with ID, and then version field, and the version field is automatically increased by the framework, by Hibernate, for instance. And it is checked with the database. So if you have your old version in the cache and you try to write it back, you get optimistic logs, because what it does behind the scenes is update where version equals version. And if it doesn't equal, you get the optimistic log exception, doesn't in one statement. And funny, because at the beginning of the entire persistence, the frameworks couldn't create or didn't create one update with the check, so they created two statements, which was bad, because behind the statements they can be in conflict. But I'm with you, but a little bit, let's put it this way. So if you have, let's say, we just like to store configuration in the database, right? So then what I could do is I can have one Java object, I put entity on it, ID, and I'm done. But if the performance is not enough, or I would like to do more, now we have more options. So I would say, this is why I ask about JDBC. So my feeling is right now, with Java 21, JDBC, streams, Java records, sealed interfaces, you can write in no time your own, database query, not layer. You can just, query a database and get the results back and pass them in one method. So it's not even write your own layer, just do it. And but with JDBC 1.0, it was a little bit problematic. So there were no, there were no Java records, there were no sealed interfaces. So the Java was too chatty to do that. And right now, I will still, in some cases, start with JPA, and then if I see, okay, and now I need the power, then I would just go straight to JDBC without any framework. So not even, they're like Jockle or whatever, JQL or all the. I wouldn't use it. I would just, as you said, then I really use the database. And in my opinion, I would have nothing against stored procedures in the database as well. So I don't know what's your part is or the function. So in Oracle, it's called stored procedures. Sometimes you have to do this because you cannot just, move the data out and then back. If you have a high bandwidth, better to use, I think it's called functions, right? In Postgres, or
it's also procedures. Yes, you
procedures.
can have both. Actually, they're slightly different. But I mean, this is a big topic. I don't know where to get started on. I could start first of all that saying that I don't particularly like IDs as part of an entity.
Okay, then here's my proposal, because we are almost over time. So this is actually my estimate that we won't manage to talk about Postgres at all, which is so I will invite you back, of course, and the first topic is going to be stored procedures, and then hopefully Postgres is the main topic. Because I'm interested, and one point of time, I would like also to talk about your Java Cloud Quarkus involvement and your Docker stuff. But I think for the community, the JDBC is a very important topic, and there are lots of confusion. And I got the question all the time. So okay, let's talk with an expert about that. Which AHC, right, or AHT.se.
ES.
Yeah. Yes. Oh man, completely wrong.
AHT. No, it was pretty much there.
Okay. Then I would say where people can find you. So we already said it. It is.
Yep. AHT.es. That's the easiest way.
And the company name is Ongress with one S.
Yes, with one S, because it's a short for on Postgres. So yes. Ongress, on Postgres.
And Stagress also with one S. But this is like the cliffhanger for the next show.
Perfect.
Cool.
Sounds great.
So thank you a lot. See you next time.
Thank you very much again for having me.